guys, welcome back to the channel Mathophile. We will now practice some of the question of the type find the principal values of the following. So the first is sine inverse of -1/2. So in this question we will first let the sine inverse 1/2 to be x. We will know that sine inverse goes to the other side and becomes sine, so sine x becomes 1/2. So we know that 1/2 is sine 30, which is equals to sine pi/6. Oh, -1/2 -1 minus. So x will be equals to -pi/6, which is in the range of sine inverse, which is -pi/2 to pi/2 within the closed bracket. So the principal value of sine inverse of -1/2 is minus of pi/6. Cos inverse of -√3/2. So now we will let the cos inverse -√3/2 to be y or any other variable that you like, and we will write that cos y is equals to minus of √3/2, which is cos y is equals to minus cos pi/6. But as we know that minus pi/6 doesn't belong to the range of cos inverse, which is 0 to pi. So we will take it to a quadrant where it is a negative, so we will take the second quadrant, pi minus pi/6, so y will be equal to 5 pi/6, which lies between the range. So we will write the principal value of cos inverse √3/2 of minus is 5 pi/6. It is the third part, tan inverse of 1/√3. So first we will let tan inverse 1/√3 to be x. You can take any variable of your choice. So tan inverse 1/√3 is x. So tan will go to the other side, tan x will become 1/√3. As we know that 1/√3 is equals to tan 30, which is pi/6. So x will be pi/6, which is in the range of tan inverse, and the range of tan inverse is minus pi/2 to pi/2. Please concentrate that these are not closed brackets, these are open brackets. It means these two values are not included in the range. So we will write that the principal value of tan inverse 1/√3 is pi/6. The fourth part is tan inverse of -√3. So we will first let tan inverse -√3 to be y or any other variable of your choice you can take. So when we know that when tan inverse goes to the other side, it becomes tan. So tan y we write is equals to minus of √3. We know that √3 is equals to tan 60, which is tan pi/3. So we can write tan pi by 3 for root 3.
Sorry guys, due to some technical reasons, I was unable to record that another part of this question. So I will show you or tell you, and this is the picture of the solution. So we will take y to be minus pi by 3, as tan and tan will cancel out each other, and as we know that range of tan inverse is minus pi by 2 to pi by 2. We write that principal value of tan inverse minus of root 3 is pi by 3, as it is in the range.
First, in this part, we will let cos inverse minus 1 by root 2 to be any variable, let it be x. So we know that when cos inverse goes to the other side, it becomes cos. So cos x is equals to minus 1 by root 2. So we will take minus outside and write cos x is equal to minus. We know that cos 45 is 1 by root 2. So we will write cos pi by 4. So cos and cos will be cancelled out, and we will be left with x is equals to minus pi by 4. And now we will see the range for cos inverse, which is between 0 to pi. But as we can see, this does not lies between 0 to pi. So we will take it to the quadrant, which is in negative form. We know in second quadrant it is in negative form, so we will write x is equals to pi minus pi by 4. So it will become x is equals to 3 pi by 4. And we have let that cos inverse minus 1 by root 2 to be x. So we will write principal value of cos inverse minus 1 by root 2 is 3 pi by 4. Here is cot inverse of minus root 3. So we will first let cot inverse of minus root 3 to be z, or any other variable we have taken z. So we know cot z is equals to minus of root 3. Cot z is equals to minus, we will take outside, and it will become cot pi by 6. As we know that cot 30 is root 3. So z will become minus pi by 6, but the range for cot inverse is from 0 to pi. It can't be negative, so we will write that principal value of cot inverse minus root 3 is, so we will take z is equals to pi minus pi by 6, which is 5 pi by 6, as cot is negative in second quadrant. So we will write 5 pi by 6. So in this part we will do this question, cosecant inverse of minus root 2. So we will let cosecant inverse of minus root 2 to be x, and cosecant x will become minus of root 2. So cosecant x will become minus of cosecant pi by 4. So x will become minus pi by 4. As we know that range for cosecant inverse is minus pi by 2 to pi by 2 except 0. So minus pi by 4 is between this range, so we will write that the principal value for cosecant inverse minus root 2 is minus of pi by 3. We have here cosecant inverse of 2 by root 3. So we will first let cosecant inverse 2 by root 3 to be x. When cosecant inverse goes to the side, it becomes cosecant. So cosecant x will become 2 by root 3. So we know that in sine root 3 by 2 is sine 60. So it will become cosecant x is equals to cosecant pi by 3. So x will be pi by 3. As we know that the range for cosecant inverse is minus pi by 2 to pi by 2 except 0. So we will write principal value for cosecant inverse 2 by root 3 is pi by 3. We will do another part. Secant inverse 2. So we will first let secant inverse 2 to be x, and then we will take secant to the other side and will become secant x is equals to 2. So secant x will become cos 1 by 2 is sine cos 60. So it will become secant pi by 3, which is secant 60. X becomes pi by 3. As we know, range for
Secant inverse
is minus 0 to pi except minus pi by 2 except pi by 2. We will write that the principal value of secant inverse 2 is pi by 3. Thank you guys for watching this video. Please subscribe to my channel and comment your queries or any other question you have related to this chapter, and I will post a video for that question. Thank you.